Hi, physics. Mr. Janowski here. This is chapter 13, homework 1, problem 4, and I'm going to show you a couple of things that will be very useful in doing all the problems throughout this chapter. So, how do we read a table like this? What does this actually mean? And how do we do scientific notation in the calculator? So, let's get started with that. So, first things first, when you look at this table, all right, this column's not so bad. This is the mass of the object we're talking about in this table, the sun, the earth, the moon, or Mars. Well, this column's obviously easy. This is the object itself. And then you have to make sure you know the difference between the next two columns. So one of them is radius and one of them is radius of orbit. So in each different problem, read it carefully and decide which one of these things you need. So for example, so here's the sun. And then some way out here, we have the earth. So clearly not to scale because the sun is in fact much bigger than the earth. Astronomy students know that. So the Earth is a sphere. It is actually a sphere. I promise you, it is round. It's not a perfect sphere. It's an oblate spheroid, but that's not the point. Yeah, the Earth is round. So the Earth has a radius. So this radius here is this number. That's what radius means. That's the radius of the object itself. So that one there is radius. The next column is radius of orbit. So what that thing is the distance actually measured center to center, but don't worry about that for now. So that one is radius of orbit. So that would be this number. So that's what those two things mean. So make sure you're looking at the table correctly and grabbing the right thing. And now to show you how to do the scientific notation in the calculator, let's just actually start doing the problem. So we have Alice, who has a mass of that. She's standing on the surface of the Earth, and we want to know what is the force of gravitational attraction between her and the Earth. And to simplify this, we're going to assume that the entire mass of the Earth is concentrated at its center. So yeah, step one, what are we looking for? What we want is the force of gravitational attraction between her and the Earth. So what we're really looking for is F sub g, question mark, and what units will it have? Newtons. So F sub capital G, that should be a big G. I mean, that is a big G. It needs to be a big G. So how do we do this? Do we have a formula that can get us this? Well, yeah, this is just the first homework. So we really only have one formula. We have a formula and a constant. So what we have is F sub big G is equal to big G times M1 times M2 divided by the distance between them squared. So sometimes we use a D here, sometimes we use an R. I'm going to go with D. Because it's not always going to be a radius of a thing. So it's distance. So one thing people have trouble with is notice the G is sitting out here on the side times this fraction here. So this is completely equivalent to this. So people get confused when they're putting it in the calculator. Traditionally we put the big G out here to the side. I think because it's a constant and the other ones are variables, so we try to do that. But yeah, this idea here is exactly the same as this idea here. So that's how we're going to enter it in the calculator. So what does that mean? What are we doing? We're going to go F sub G is equal to, and then we're going to write in all the numbers we're going to use. So big G, if you look at the footer, pretty soon you will have memorized this number and you won't need to look at the footer. 6.67 times 10 to the minus 11th. This thing comes up throughout the chapter. So I'll write in the units here, although usually we're going to get lazy and we're going to leave the units off of this constant here. We'll have the units in our final answer, but this is annoying to write every time. So yeah, we have that times M1. All right, so let's say Alice is M1, and we'll make the Earth M2. So 55.0 kilograms times M2 is the mass of the Earth. So that's going to be this number. The Earth is a big, massive thing. 5.97 times 10 to the 24th kilograms. So that's the top part of this expression. So that's this part right here. And then all of this gets divided by the distance squared. So what is the distance? So if you can picture, here's the Earth, And here's little Alice standing on the Earth. The distance she is from the center of the Earth is the radius of the Earth. So that's going to be this number. So that number is 6.38 times 10 to the 6th meters. And notice that this number gets squared. All right, so we've got some work to do in the calculator. And I'm going to show you a particular way to do this in the calculator, and you really want to do it this way. You've got to learn something about the calculator. You'll be using it a lot in this chapter, so just learn it the right way and get good at it. So f sub g is equal to, how do we get this whole thing into the calculator? So you don't want to use a million parentheses and multiply things by 10 and raise 10 to the power of things, because it's going to get really messed up. There's an easier, faster way to do this, and you might as well learn it now. So the first thing we have is 6.67 times 10 to the minus 11th. So what you actually key in is 6.67, and then this is going to vary a little bit calculator to calculator, but on mine, you hit the EE button. So on some other calculators, that might be just a big E. It won't be a little e. Little e means something else. That's Euler's number. You might have a button that is 10 to the x. You might have a button that is 10 to the box. Or depending on your calculator, you might have to hit the second button and then find the thing. So this is one of the reasons I love the TI-36X Pro so much, is because there's a dedicated button for this. I don't have to hit second, and it makes it faster. So it's quicker, and there'll be fewer typos. Oop. So let me undo this little bit here, because I don't want that here. But anyhow, what you want is 6.67 EE. However your calculator does it, you want the EE. And then minus 11. So how do I do that? There's another button. So this is the negative button. It's not the subtraction button. On my calculator, it looks like this. And then you hit 11. So that idea there is this idea right here. And then we have to multiply this by 55. So hit the multiplication button. 55.0. And then we have to multiply this by 5.97 times 10 to the 24th. So you hit multiplication again. And then you type 5.97. And then how do we get this other part? EE 24. So this whole bit that I've done here, this is the whole top part of this. That's what that is. So if you want, you can hit enter or equals or whatever and get a value for this and write that number down. But as you get better at the calculator, you'll learn how to do this whole thing in one big shot, and it will be easier. So I'm just going to continue and show you the one big shot way. But if you're doing these problems and you find you're getting stuck, do it in parts. Like do the whole top half, hit enter, write that number down. Do the whole bottom part, hit enter, write that number down, and then the first number by the second number if you have to. But I'll show you how to do it all in one shot. So now what we hit is divide by. I'm going down a line because I'm going to run out of space left to right if I keep going. So divide by 6.38 EE, and then it's 6. And then this number gets squared. So here's an order of operations thing. On my calculator, there's a button that says x squared. So if you enter this in the calculator, it might look like it's only squaring the 6 part and not the whole thing, but it is actually doing the whole thing. So you don't need parentheses. If you want to have parentheses, it wouldn't hurt. You could add a parentheses here in the calculator and a parentheses here, and then hit x squared, or then hit the caret up and raise it to the squared, or hit x to the box and then 2, or anything like that. But you don't actually need those parentheses. So I'll tell you what, I'll get rid of them. So if you do all that, and then you hit enter, what number do you get? I'll tell you what, I have got my calculator, I might as well do it. 6.67 EE negative 11 times 55.0 times 5.97 EE 24, and then divide by 6.38 EE 6, and then x squared. And again, on the calculator display, it really looks like it's only squaring the 6, but it is actually squaring the whole thing. And then you hit enter, and you get a number that says, where's the cursor? 538.0485893. So we'll just call it 538. And what are the units of this thing? Well, we found a force, so it's Newton, so you can just go with it like that. Let's say newtons. You can, if you want, actually go up here. I made a mistake up here. And follow the units. So if we're looking at the units of big G, newtons times meter squared. Okay, well, this meter squared is going to cancel with this meter that gets squared on the bottom. So all those guys go away. Divided by kilogram squared. I forgot to write that 2 in there, but it should be there. So divided by kilogram squared, but times kilograms, well, all that goes away. Then you end up just with newtons. So step, did we solve for the right thing? Did we give it the right units? Yes, we did. We've solved for f sub g. It has the right units. So I'm giving it a check. So hopefully, well, let me put it this way. If you haven't had much experience with scientific notation and using your calculator, well, rejoice, be happy, because you're going to get a lot of experience using scientific notation and how to use the calculator. These will be useful skills throughout all of your scientific studying careers. So be happy about that. Hopefully you found this helpful.